Hello. Hello, everyone.
Hi, doctor.
How are you, Fatima?
Fine, thank you. And you, doctor?
I'm fine. So we have very few students today, only 8 online and only one here. So what happened? Where are the students? Because I should have 21 students. A lot of absence today. Okay, so we will today finish quickly because we don't have so many students. But I will keep because I have only one student here. So most of the time I will be asking the online students to show their work. Okay. So, hello. Hi, how are you?
I'll continue to the point.
Have you studied double sideband transmitted carrier? Yes. Did you manage to upload your assessment last time? Assessment 4. Assessment 4, did you upload?
Yes. Okay. I've come from you, but not yet.
Really? Then?
On Thursday, when I finish. Every week I come.
Just email me before coming. So that, are you guys listening to me here? We have very few students today. So, okay, I start.
Midterm exams.
Midterm exam, yes.
Yeah, and we have a lot of homework to submit.
So today we will study the amplitude modulation. Previously also we studied amplitude modulation, but double sideband suppressed carrier. And today we will study double sideband transmitted carrier, but it means that at the output, when I will get these signal information, then carrier will be there. In the previous lab, this carrier was suppressed, but now this carrier will be here. Okay. So in the previous lab, what did we do? Anyone can tell me what we did in the previous lab? We generated the
Modulation.
Yes, we did modulation, but we were only at the transmitter side. We didn't send it and we didn't receive. So what we did is we generated the message signal, we generated the carrier, and then we modulated. Then we plotted frequency domain figures, and then we plotted time domain. Okay. Today we will do the same, but we will also transmit the signal, and then at the receiver we will pass it through the low pass through the filter, and then we will get our estimated signal. Today we will do this step also. Okay.
Demodulation.
Demodulation, exactly. Demodulation also today. So this is my transmitter. What we do in the transmitter side means sending side. At the sending side, we generate the message, we modulate the message. How we modulate the message? We multiply this message with the carrier. That is modulated signal. Message plus carrier equals to modulated signal. Then there are different techniques of modulation: analog modulation and digital modulation. The types of analog modulation are amplitude modulation, frequency, pulse width. So these, and then with the digital, amplitude, shift keying, frequency, this. But today our focus is amplitude modulation. Okay. So this part we did in the previous class. Okay. What was that? Message signal. Then we multiply it with the carrier. We transmit it. We add this offset in the message signal. Do you have any idea why we do that? Our, for example, message is like this. We add this DC offset to shift this scale exactly here. That's why we add DC offset. Okay. So then we multiply with the carrier. Then here x of t is equals to a plus
Miss,
m of, yes.
will be 2 signal when I multiply by cosine.
Not two signal, one signal. This plus this. This offset is added with the message signal. This is my message signal. Then I will add the DC offset. Then I will multiply with the carrier. This all becomes one signal.
Okay, clear.
X of t will be how much? Just from here. You're also studying control. So m of t plus a multiply with this cosine of 2 pi. Yes. Okay. Then we will send it to the channel. Then after it is passed through the channel, then we will use this. We will use this rectifier so that, for example, after, because I added the DC offset, my waveform will be like this. Okay, will be exactly distributed. By using the rectifier, I will remove this part, this down part. I will get up. Okay. Then I will pass it through the this filter, and then there is also carrier inside. There is also carrier because my drawing is not very good. So in order to remove this carrier, I will use this filter. Okay. Then at the output, I will get my message. Okay. So this is the idea. Is it okay? Clear? So what happens at the transmitter? I just explained. Message signal, DC offset, and carrier. This transmitter is here. It's all is coming. Channel will pass through the channel. At the receiver, receive signal. Again, we will multiply with the carrier. Then from the band pass filter, then this is my original message signal, which I sent from here. Yes. So these block diagrams are very important because these block diagrams will help you to write your code. You will see, okay, there is a message signal. You will write message signal. You will write carrier. Then you will multiply. Then you will send it. Then all this procedure you can do if you know this diagram. You are. It will be easy for you to write the code. Okay. So this, if the channel is without noise, then we don't have to do anything. But if the channel is with noise, then we have to write the noise information also. Okay. So then we have to write the noise information. Then we will add the noise to the signal, and then we will plot the message with the noise signal, if there is noise. Okay. Then noise information will be given in the first. Okay. Then add this noise, so you will be doing this. But here today we are not going to do this. So this step we did in the previous class also. But there is one more thing, DC offset. We didn't add this in the previous example, previous class. So first, this step transmitter. So this is my message. First of all, this one is here. Okay. Then DC offset, this one here. Same, we will write the code as it is. Then carrier, and then multiply this step here. Okay, you see. Then at the receiving side, my message signal, receive signal. A0 plus M of t into C of t. This was my transmitted signal. Then what is happening here? Filter input. A0 M of t into AC cosine of this. This I received. Okay, C of t is this, and then this is here. Okay. Then I will multiply it with the carrier again. Okay, here. Here, this is receiver. And then in the previous class, I showed you that if this is cosine of alpha and then cosine of beta, then this is the trigonometric identity. Yes. So then by solving, then I have this signal now here. Here. So after sending through the bandpass filter, this part will be removed, and then I will get my estimated signal here. Okay. So these are the steps. If you remember them, then it's very easy to write the code.
These steps without noise, right?
Yeah, without noise. Yes.
Okay.
No noise. Then, so narrow pass band filter, I explained you also before that, but this is the rectifier. So what it will do is it will remove this part and then it will only give pathway. Then we have, after passing through here, I get this. After passing through here, I get this. Then after passing through the filter, I get this. So this is my estimated message signal. Okay. So how to design the filter? In your signal and system, did you study about filters? Filter response, Butterworth filter, Chebyshev filter. Okay. So this is a type of filter which is Butterworth filter. It has this frequency and then it has this order. And then these are the numerator and denominator of the filter. So to write the filter step, you have to write these two commands. Okay. So for the mathematics and all of this, I will not go through that. I will just tell you that this is a filter, this is the order, this is the frequency, and then these are its input arguments, which are numerator and denominator. Then filter order, and then this is the frequency, where, for example, if my filter is like this, for a low pass filter, then this will be the cutoff frequency. Did you study this?
Yes, yes.
Yes. So
The low signals will be passed.
yes, low frequency.
Yes.
And then high pass, high frequency components will be rejected.
Yes.
So this is then you have to write filter A, B, these arguments, and then this Y. What will be the Y? Y will be your this signal. Your this signal. Here. So Y will be your this signal with the carrier. Then it will pass through this and then. So this Y will be your signal plus carrier. Here. Then filter input signal. So which signal you want to pass through, that will be, and then this is the time scale. Okay. So I told you this is starting time, then this is the sampling frequency, and then this is the number of cycles at the output divided by the frequency of the message signal. We did this in the previous class. So this, and then this is number of cycles. So then this step, can anyone tell, because since 3 labs we are doing this, what does this FFT means? What it do with our signal? What is the output of FFT? For example, if I have my time domain signal, for example, this is x of t. If I transform it in Fourier, I will get something like this. Yes. So my frequency will be exactly like here. So if I take the FFT of this signal, it will give me the frequency response of this time domain signal. So FFT will give me this frequency response of the time domain signal. You were 20 minutes late. Last time also you missed the lecture. You know that lecture is only 20 to 30 minutes.
I was in the.
How? The last time also you said that you will do it yourself.
I was in the.
Okay. So, if next class 10 minutes late, I will not text.
Okay.
Okay. So, and then FFT shift, what it does is,
Signal shift.
yes, signal shift exactly at 0 point. So equally distribute the frequency components. Okay. Then, so modulation index. Does anyone have an idea what is this? We are doing the amplitude modulation. For example, if my amplitude of carrier is like this, then what happens in, and then if my signal is, so with the amplitude modulation, for example, my signal is like this, so amplitude of the carrier will vary like this. Okay. So this modulation index will tell that how much variation in the amplitude will occur. And its value is ranged between 0 to 1. If the value is less than 1, this is under modulation, which we don't want. Means that there some of the information will be lost. If this is greater than 1, this, again information will be lost. So we want modulation index to be between 0 and 1. The variation in the amplitude should be between 0 and 1. Okay. So this is equals to MP divided by A naught. This is the
Stay. Yo.
so okay, so this modulation index is equal to amplitude of the message signal divided by amplitude of the carrier signal. Okay, or the offset, DC offset. Okay. So this is my message signal, right? So this is the amplitude of the message signal. Okay. So if my message signal is less than 1, then if this is my carrier, so what will happen? This is fine. This is greater than 0. This is less than 0. But this is fine because now I am getting my information at the output. But what happens here? This information will be lost if it is less than 0. This information will be lost. This will be lost. Okay. So we avoid this. Okay. So that's this. This is also the reason we are adding the DC offset to shift the signal towards the positive 0 axis. So here the cases which I was telling. So under modulation, if it is less than 0, 50%, then this is the perfect modulation here. So this is 100% modulation. This is over modulation. Here, this much envelope is lost. Okay. So then, now the question. So always remember this block diagram because this will be very helpful for you to solve the problems related to modulation and also writing the code for the examples or for the questions. Okay, so using the MATLAB to simulate the given system, the modulation index, the message signal is 5 cycles. Okay, and frequency. In time domain, it should be 5 cycles. Okay, and then we have to write the message in frequency also. Then the carrier in time domain and frequency. Same step we did in the previous class. Then transmitted signal, both frequency and time domain, and then estimated signal at the output. This is the new step which we will be doing here. This is the new step which we will do it today. So the noise, there is no noise in the channel. The amplitude of the message is 1 and frequency is 20. Right? First of all, you will write the message signal with the frequency of 20 hertz and amplitude 1. Then you will write the carrier with amplitude 1 and frequency 500. Then you will write the sampling frequency, which is 8 kilohertz, and then your filter is first order, and then cutoff frequency is 0.1. You remember that command button of 0.01 is equals to, you have to write the proper command AB, then something Y is equals to filter of A, B, and then your input signal, whatever is XT or. Okay, so this is for this step. So add DC offset of 1, 0.5 and 2. Okay. So this is the procedure. You can copy the previous lab and then start. And this file is available on the Moodle. Did you download? Yeah, lab number 5.
No, it's not there.
It is on the Moodle. Showing here.
Example or lab?
Example.
Yeah, examples
Example is there.
is there.
In,
Lab is not there. PDF file.
no, PDF is not there. I will put it. So this is lab 5. And also I uploaded the assessment. So for all the online students, please download this and then I will check your work. Okay. So, okay, so first of all, define the carrier frequency. Define the message frequency.
You have not the lab file?
Assessment, yes.
Not necessary. Lab. PDF file.
Not yet. This one,
Yes.
not yet, but I will upload it. Okay, so it's there now. Hello. Did you understand today's lab? Yes?
Yes.
Same steps like the previous, but a few changes will be in the coming slides. No, don't change. It's the same, but try to see that what is happening. So it's very like if you write with your own hands, you will understand more. That's fine. So how's it?
بس هي تبي شنو خطوات المكتوبة الفاونديشن تمام هو اصلا رجع على واحد مكتوب شنو كان بالأصل
What one did it tell?
For 3 to 400, I can do now any. For
Since
one,
the first lesson.
yeah. For one, I check I clear from this, but
شو حاجة بالي الحمد لله.
yours is
Yeah, she's excellent student, right?
yeah, she is one.
مين تو؟
أو حتى محمود مو عبد الحميد محمود أصلا محمود.
I'm good.
I will check your no, he's good. He's good. He's doing his work here.
Yeah, and then my lab is also excellent.
Which one?
For electronics.
Ah,
He understands the concept.
yes, yes. Yes. And Abdullah.
Yeah, Abdullah is perfect. Yeah, as far as
When you get free, just call me. I will be in my office.
when I finish.
Yes, thanks. I will know. Okay. Okay. So done. Okay. The question is some part is missing. So then it's here. See this? The carrier frequency. Okay, I put this here because this part is not available in the. No, don't change. It's the same. See, carrier frequency is 500. Look there. 500 and amplitude is 1. Then message frequency is 20 and amplitude 1. Amplitude for both carrier and message is same. Then sampling frequency 8,000, 8 kilohertz, 8,000. And then, yes. Is it fine?
Yes.
If fine, it's fine, or I should turn it on. Right? It's okay. It's okay. Okay, I'll keep it. Do you understand the No. What? So then, done? Done?
I'm fine.
So then, what we do is define the carrier, define the message, add the DC offset, modulation index. These steps are new.
Yes.
For the online students, I want to check your work one by one. Okay? And then if you are not able to show me, then minus. So Orub al-Dafiri. Orub. So, okay. Orub, if you are not here, then minus is for the class participation. Saud al-Kazimi.
Yes, miss. Can you read the chat box?
Yes. So that's your first time? Why? You were here before also. He was with you?
No, miss. I told you this first time. I tell you that I cannot.
I was here. He's at work. Okay. So, okay, I was asking. Okay, so it's fine. He was working here in the last class
Yes.
with
My
you?
friend, yes.
Okay, I forgot. So, Ritaj Mohsin. So, Rawan Al-Khalbi. Because your this session was on site, none of you came here, and also you are not participating in the class. Only 4 students here. So this is not good. I mean, this is not fair with the students who are here.
Yes, miss.
So Ritaj, can you show me your work? Are you working with me?
Miss, just I need 2 minutes. I'm still working on them.
But okay, if you are done half of the work, can you show me?
Yes, sure. Okay.
Okay, I stop sharing. Okay, show me. Can you show me your work? Ritaj.
Yeah, miss, I told you I just need 2 minutes to finish it. Just 2 minutes, please.
Okay. Then Fatima Al-Kawandi. Fatima Al-Kawandi. Mefle, are you here? Mefle Mutayyar. If you are only sitting on the Zoom and you are not doing any work, so this doesn't mean anything. It means that you didn't even notice the lecture. For these students, I will not change anything. Dana, are you here?
Yes, miss.
So can you show me yours, please?
Miss, I'm not finished yet.
Okay. So Noura Al-Mutahri.
Miss, now do the example of the.
Yes. Yeah, we are doing this. So, okay. So now from here. So next was this one. Until here you are done, right? No, let us assessment. This one. Let's go down. No, this is assessment. Examples. Here is example. Example from who did you download?
أول شيء الفلات فوق
Example this. Okay, it's there. Other. So did you see the step that here what we are doing? Until here it was all T means time domain. All the things were in time domain. Here we are doing the same step which we did in the previous two classes. We are taking the frequency, Fourier transform of carrier, Fourier transform of message, and Fourier transform of x of t. What? Okay. So see, until here, this was these steps are new. This DC offset. Okay, but this is the old one. So we have defined our carrier, this one. We have defined our message, and then we have our x of t. Right? Now we will put all these three, and then we will take their Fourier transform. We will transform them in frequency domain. Okay. So same step, absolute value of FFT shift, frequency, Fourier transform of carrier. That one, frequency transform of message, and frequency transform of this signal. XT. Then this is the scale, normalized scale. Okay. This n you define here. This goes until this. So we put it here. Okay. Then after this step, only plotting. Until here, all these steps were done in the previous class. Yes. We then what we will do in the next is this one. Now at the received signal, we got our received signal here. We multiply it with carrier. With carrier again, same carrier.
Yes.
Then this is these are two steps for the filter here. Okay, and then simple. I will. Which signal is this one? M. Message. Yes, I will plot the time domain message signal, and then I will plot this one. My estimated signal which I received here XM, I will plot, and then I will try to see that if my message signal is this received signal is almost same as message of function. Sorry, estimated is XM, and then this is my original message signal which I generated in the start. So I will compare them. Then, so I will get these three figures for the time domain, carrier, message, and then modulated signal. Then this is the Fourier transform, and then here see at the modulated signal, what is the difference between the previous lab and this lab? What is the difference which we are receiving here? Yes. Yes. We didn't have this carrier, but today see in this lab, because this is double sideband transmitted carrier. So carrier is here. Exactly at which frequency? 500. So frequency of the carrier was 500. So exactly in the middle, this is 500. You know how to read the scale.
Yes.
So here the frequency is 20. The message signal frequency was 20 hertz. And there it's 500. So this is the difference. Okay, then this is my original message signal, and then this is my estimated signal. You will get these figures. Okay, so here this modulation index mu was equals to 1. So you got this modulated signal. Then when mu is equals to, in this case mu is equals to 2, then this much information is losing. because this is greater than 1. Over modulation. Yes. And then in the third one, this is 0.5. So this is perfect because none of the information is lost.
Okay.
Right? So that's why this value should be between 0 and 1. Okay, so we will check all these 3 cases and then this
Between 0 and 1 will be perfect.
will be perfect modulation. Okay, so you just change the value of the mu. You will just write one code all until here, and then you will change this. Okay, because this is mu is equals to am divided by a naught. Now in this case, my am is 1, a naught is equals to 1. So modulation index is 1. So how can I make it 2? 2.
2 over 1.
2 by 1. Yes. So am equals to 2, right? And then 0.5. So this will be 2. This will be 1. Then it will be 0.5. 2 and then 0.5. We'll check 3 cases.
AM will be 2.
Am will be,
A naught will be 1.
a naught will be 1. Then it will be here. Yes. Am equals to 2, a naught 1.
Yes, so
2. And then here a naught is equals to 2 and 1. It will be 1 by 2.
yes.
0.5. So you just have to change this.
So
For
I
the
have
3
to
cases.
change the AM and A naught.
Yes, am and a naught. Okay. So these are the changes. So I will check all the 3 cases from you so that you understand it. So, and Mahmoud, do you remember about the scaling? Axis scaling, this, and this. We did in the previous class, and I explained. So that's why I am doing it. So, okay. Okay, Fatima, now you are finished? Yes, Vital.
Miss, I can't share while you are sharing.
Yes. Now you can.
I did 2 over 1.
Hmm,
I did.
you did
You want now 1 over 2.
1 by 2. Check yourself that what is the. Okay, so show me. Go up and then why you couldn't get the carrier? So why you couldn't get the carrier? Where is the carrier signal? Ritaj. No, this is the Ritaj, yes. Ritaj, where is carrier?
There's something missing, you mean?
Yes.
Okay, I'll check again.
Yeah, something is missing. And okay, I say some other names.
Miss, I saw you write down my name. Is there something wrong?
Who is speaking?
Ritaj.
Raj, yes. I wrote your name here because you were not participating in the class.
Oh, okay.
So then if you will show me your work, fix your problem, and then here it's your -4. And the
Show you.
students who are absent today, they will get -4. Okay.
I just show you. I just share my screen.
Yes, sir, but Rita, there is something missing. You couldn't plot the time domain signal and domain signal.
If I fix it, you will remove the -4, right?
So I will ask some other names and Ibtihal. Ibtihal. Ibtihal Abdul. Ibtihal Abdul Aziz. If you are here, then share me your work. Otherwise, this is your marks from the report.
هذا المسج تسوي كوبي مش عارف. ثانية خلينا 2-1.
Dana, you just joined. Dana Talal, did you just join?
No, miss, because of the net.
Okay. So Dana, I want to see your screen. I want to see your work. So these students, Ritaj, fix your problem. And okay.
Yeah, miss, I'm working on them. Okay.
So Ravan. Dana. And Ibtihal.
I'm here, miss, but just 1 minute.
Okay. Who has the problem? He told me. So Ritaj. She's joined me. Ravan, Orud, Noura. There was another Noura, she left. Left leg. Fatima Al-Kabandi. Fatima Hussain.
Yes, miss.
Yes, Fatima, can you show me your work?
Okay, I will share now.
Okay.
Okay. But I'm not finished.
Okay. Okay, you are Fatima. Okay.
Yes.
So Fatima, what you are doing?
What?
What you are doing until now? Go up.
Up?
Yes. Okay. Okay. You are plotting time domain signal, right?
Yes.
Just I will see the figures.
What I do?
Yeah, run it. Simulate it.
Okay, wait. Yeah.
Okay, so
Yeah.
go up. You missed C from here. You didn't define the carrier. Here, define the carrier also.
Okay, I will fix it.
Carrier is equal to AC, I think, or A naught into cosine of 2 pi F. This should be FM.
It should be what?
FM.
Here, FM?
Yeah, FM. And then you didn't define the frequency. Go up. FM, FC. Okay. No, not this one. This is
What?
this is only C. This is only C.
See this one?
Uh,
Because I do what you do. Okay, wait.
no, you missed some of the things.
I must see. Yeah, this
C is equal to
is it.
AC into what? Cosine of 2
Two
pi FC
FT.
into T.
Okay.
So let's see.
But who put A here?
This is 2.
Yes. But I didn't finish, I think, because of this.
No, not because of this.
Okay.
This is M. Yes, this is carrier. So why this is 5 divided by FM, 5 divided by 20 is 0.25. Yes. What happens here? Here is the carrier. This figure.
Oh, the first one, CC miss. The first A axis, it will be FC, not FM.
This
FC, yeah, here.
one.
Right?
Yeah, now this is fixed.
Okay.
Exactly at 500. You said. Okay, good. So then make it the next. Write the next.
I will write, yeah, have a little bit.
And Orub, are you finished? Have you done? Okay, so these students, Rita, she showed me her work. So
Miss Hamdan, can I show you again?
who is there?
Ritaj.
Rita, you just showed me. Who is with me now?
Fatma. No, Fatma, not me.
Which Fatima, you are here? Fatima Al-Kabandi?
No, it's Fatma Dashti, just before me.
Okay, so this Fatima Hussein, who? Because
Yeah, me now, I show you, and we've fixed together.
so Ravan, you didn't show me. Okay, then. Mahmoud, done? Did you understand the lab?
Yes, I have a question about the assessment. What means modulation index?
In case one.
Okay, if I did case one,
Yeah.
offset.
Then DC offset you will put 1,
Okay.
and then you know that modulation index is equal to AM divided by A naught.
Okay.
From there, with the even okay, this here, if you just put you get this modulation index 0.5, and then you will do the same. This is the modulation. You can just write percent so that you know this is 0.5. So you will tell that you will see it from the MATLAB, and then you will write.
After coding, I write the answer for this question.
Yes.
Okay.
Okay.
And this one,
In
the
case two.
case two, it's okay. The type, okay.
Type. So it is under modulation, over modulation.
Over one, less than
Yes,
0,
yes,
and between.
yes.
Okay.
When modulation index is greater than 1, greater than 1, over modulation, less than 0, under modulation. Yes. See this. So you know that how to give the because this is what it is. Okay. Then so you didn't do this part of plotting the basic signal and then the estimated signal. Yes. Yes. 1 minute. Okay. So. This part, Heather, this one, this part, yes. Good. So, can you change the modulation index to 2? Yeah, this is 1 now. 2. Make it 2. This one. Yes, 2. Then run it and then see how it will affect. See, yes. Now this is over 1. Then the assessment this time is very easy. So make it 0.5. 0.5. How? No. AM 0.5. Where is the button? This one. Okay. This will be the perfect modulation. Go down. Here. Good. Yeah. Okay, then 3. Okay, Mahmoud. Yes, that's it. So,
Can I share?
who is here?
It's Haj.
That I saw your. Okay. Share your screen. So. Go down. There was problem with your divided by 5. Because this is should be 1.
وعندك فورمولا اللي هو اي ام على الاي نوت تبينها 2 شلون تصير؟ تصير 2 على 1 تصير 2 تبينها النص تصير 1 على 2.
The laptop is slow.
Yeah, let's.
Okay, so then
لا انت الحين خلي المعادله عندك صح؟ اللي هو الاي ام على الاي نوت 3 حالات عندك تسوي الحاله الاولى خلصنا الحاله الثانيه 2 على 1 الحاله الاخيره تبينها نص تصير 1 على 2 1 تقسيم 2 هي نفس النص 0.5 فهي تبين كذا راح تغيرين الاولى والثانيه
with capital C, this one, FFT shift. Why doesn't give you the result?
الحاله الثانيه بس
Maybe because I'm using MATLAB, online MATLAB. It's like
Let's see.
شنو؟ لا هي بس تغيرين تسوي الرن راح يطلع لك النتائج
2 pi FCE 2 pi SMT.
اساس مثال لازم تحلينه وتسجل له
These are correct.
طب شنو
Until here correct.
submission
Then what happened here? What is the mistake? I can't figure it out.
for the assessment the line of space will be the same right?
Yeah, it's up to you. You can put it. Just change it and then when
Change down plus use other frequencies. That's
yes, it's easy. This is very straightforward. The previous was also easy. Here you are getting the correct. But what's happening here? 0.6 should give you the result. Let's check it with my work.
Miss, she have the M. After the M, she should put the C. She didn't. She didn't put at small
Line.
M. No, before.
This one
No, before.
here.
No, up.
أي سطر
فوق سطر 13 كذي. هي مو مبينة.
It's line 13 she's saying.
See after the M, 10, sorry. After the M, you see the line 10. After the M, she should put the C, but she put it up.
I don't know. Until there is some problem with her code here.
Wait just a second, miss. I will check.
Let's check it with this one. Okay, so this was Vitaj, can you share again?
Yeah, okay, but you should stop sharing first.
Yes.
I just changed here. I AM and then I changed it to AC, but there is nothing different in here.
Oh, this is AM.
It's AM.
AM divided by 2. Don't know why. Online, it should not make any problem.
Okay, what is the motivation?
Try to copy the code from here. But you already put it same. But anyway,
Miss, the thing is, I can't copy paste anything in here.
possible.
I can't copy paste in the code. There's nothing. There's nothing like that.
Because your code looks correct to me. I can't figure out what is the problem.
Yeah, I don't get it.
Did you define the scale F? Yeah. Is this right?
Yes.
كان حلقات صغار كان في حلقات صغار هذا راح يكون اقل من الصفر.
Okay, because you put here, this is F, S.
Oh, okay.
Let's check now.
Yeah, it worked.
Now this is fine.
Okay.
So, Ritaj, can you tell me how much is the frequency of this signal, carrier signal here?
3.5.
In this figure, carrier frequency.
0.5.
No, this is the amplitude. Frequency is here, 500.
Yeah, 500 minus 500.
It's also given in the question. Here. This one.
500, right?
Okay, so okay, Ritaj.
Okay.
Okay, then I share my screen.
Miss, can I go? I finish, or we have.
I saw your work, but okay. So these marks will be in your reports, okay? So expect these minus in your reports. So Mahmoud, what's your student ID?
17
17
21
21
55.
55. Haider,
1811.
Mariam, and Zainab. Yeah, I forget you. 182 066. Yes, only 4 students are present here. So for the okay, so these are the marks which I deducted for students who didn't show me their work. So okay, this is it for today class. So please solve your assessment, upload it. You have 1 week. You have a lots of time because of the midterm. I extended the date. Otherwise, always the date is three days. But this
Okay.
time I give you 1 week. Okay.
Thank you, Miss.
Thank you, Miss.
It's very easy. You can do it now. Mahmoud did it now.
Miss, it will extend till what?
The deadline is here. If you go, section,
Yeah, section 2.
Only lab 5.
yeah, section 2. Yes, so you can upload it until due date is, yeah, due date is here. 17, you have 7 days. Okay.
Thank you, Miss.
Okay. So, okay. This is it.
Thank you, Miss. Thank you.
Bye, Miss.